What's up, guys, and welcome back to mine and Miss Perrick's YouTube channel. So I am joined here right now with Gizmo. So say hi, Gizmo. All right, Gizmo's gonna go on and do some dog things, but you know what? So I get asked this all the time. Miss Medrano, how do you do your eyeliner? Miss Medrano, how do you do your hair? But the number one thing I always get asked by my students, can you please give us some extra practice problems? And my answer is absolutely. So that's what today's video is all about. So what I'm going to ask you guys to do right now is to take out your geometry notes packet. Okay, so for my classes, they are blue. And we're going to go ahead and turn to day 5. So day 5 right here. You also need a pencil, so make sure you go ahead and take that out. And then, yeah, we're just going to go ahead and get started. If you don't have the notes packet, that's okay. I'll I'll post a PDF copy for you to print if you'd like to follow along. If you don't want to follow along and you just want to watch the video to look at the practice problems, it's also okay. Alrighty, so this little screen right here in the corner is going to peace out, but you'll still be able to hear my voice. All right, let's go ahead. Okie dokes. And so, by the way, your homework tonight will be to try problems from homework 805. It's going to be in that Unit 8 homework packet that we initially passed out at the start of this chapter. Okie dokes. So let's go ahead and hop to it. So let's look at day 5. So a lot of these problems, guys, are just basically going to be review from what we've done before. It's not really anything new, but there are some tips and tricks for some of these. If so just keep watching, basically. Sorry, I'm like losing my words right now. Anyway, okay, so for finding the area and perimeter of a rhombus. Well, a rhombus counts as a parallelogram, so one of the ways that I can find the area of this rhombus is by doing base times height. Now, the problem here is that I don't know what these side lengths are just yet, but we can figure that out. And I don't have the height because remember, in order for me to count something as a height, it needs to be perpendicular to one of the sides, and I don't have that drawn in right now. The other formula that I can use is 1/2 diagonal 1 times diagonal 2. Now, I can use this formula with any shape that has perpendicular diagonals. So I can use this formula for kites. I can use this formula for squares, and that's about it. Oh, and rhombuses, obviously. But you cannot use this formula for rectangles. So I know that my short diagonal, I should say, measures 12. So we're going to go ahead and plug and chug. So that's 12. This other diagonal here is going to measure 20. And then after that, it just really becomes a matter of multiplication. And so you should get a final area of 120 meters squared. Okay. Now, part of the problem is also asking you to find the perimeter of this rhombus. If you don't remember, we just said that the diagonals in a rhombus have perpendicular diagonals, which means this triangle right here is a right triangle, and we can use Pythagorean theorem. I'm just going to go ahead and set that up for you guys. It's going to be 6 squared plus 10 squared equals c squared. But you guys can go ahead and figure that out. Ultimately, you're going to get that this side length is 2 root 17, and that's what this measures out to. Oh, no, just kidding. I lied. 2 root 34. So each of these sides is going to measure 2 root 34. I've got 2 root 34 as a side times 4. So that gives us 8 root 34 as the perimeter. Okay, let's go ahead and try number 2. So just looking at number 2 right now, looking at this little right triangle here, I see right away that I've got a triple. So I've got a 5 as one leg, a 13 as my hypotenuse, which means that this leg right here is going to be 12. Okay, so that measures 12 millimeters. And so part of the problem is asking us to find the area. Well, area of a triangle is 1/2 base times height. Our base is 15, so it's 1/2 15, and we just figured out our height was 12. So once again, we're just going to go ahead and multiply that, and your area should get you should get 90 millimeters squared. Okay. We're going to go ahead and do Pythagorean theorem to help us find this hypotenuse of the triangle that I just highlighted. So when you do Pythagorean theorem, you should get an answer of root 244. So when we're finding the perimeter, we're going to do 13 plus 15 plus root 244. And the only thing we can combine is this 13 and this 15 right here. So that's going to become 28 plus root 244. If you simplify that square root, it's going to be 28 plus 2 root 61. If you'd like to see how I simplified that radical, you can make an appointment with me and we'll set up some office hours for you. But you cannot simplify that further because it's just like saying this is not like terms with this. So we cannot combine them further. All right. Excuse my sniffles. All right, on to the next one. So just like we ask you guys to find the areas of certain figures, we also want you guys to work backwards. So number 3 is a perfect problem where we're being asked to work backwards. And so area of a kite is 240 inches squared. Now, if you remember from what we were talking about in number 1, the formula that we're going to reach for is area equals 1/2 diagonal 1 times diagonal 2. And from there, we're just going to plug in our knowns. So I know that the area is 240. So we're going to do 240 equals 1/2. One of the diagonals is 15. So I'm going to put 15 for diagonal 1. And we're trying to find diagonal 2. Okay, so that's our setup. We've set it up and we can go ahead and simplify. I'm going to simplify the right side. So half of 15 is 7.5. So now my equation is 240 equals 7.5 times diagonal 2. Okay, now opposite of multiplication is division. So I am going to divide both sides by 7.5 and that's going to cancel out over here. 240 divided by 7.5 is ultimately going to give me 32. So that second diagonal in the kite measures 32 inches. I almost forgot my units. Okay. I'm not going to completely go through number 4, but I am just going to go ahead and set that up for us. So in number 4, find the exact area of the isosceles trapezoid. An isosceles trapezoid is just one where the legs on the sides here are congruent. So if one side is 17 centimeters, that means the other one is also 17 centimeters, okay? Now, from there, we are going to need our height. And the reason is because if we're looking for the area in a trapezoid, this is your formula. So it's 1/2 times base 1 plus base 2 times the height. I have both of my bases. Okay, so one base is 33. Another base measures 3. Ooh, that blue on blue. Maybe I should have picked a different color. Let's try green. There we go. Okay. What I'm trying to find right now is the height. Okay. And so what we end up doing when we draw both of those heights in is we end up with 2 congruent right triangles on the end of our trapezoid here. So I'm going to go ahead and bring down, if this top part right here is 3, then that means this part right here also measures 3. So that's going to come down. I know the whole bottom base here measures 33. So we're going to do 33 minus 3, which is 30. And 30 divided by 2 is 15. So that means each of these bottom bases here is 15. Now, what I can do next to help us figure out what the height is kind of hone in here on this right triangle. And I've got another triple. It's an 8, 15, 17. But you know what? If you don't have that memorized, that's okay. That's what the Pythagorean theorem is there for. So after that, we can just go ahead and plug in our knowns. One of our bases is 3. The other base is 33, and we just figured out our height was 8. Follow order of operations, and you should end up with an area of 144 centimeters squared. I said we weren't going to solve it, and we just did, so you're welcome. Okay. Let's go ahead and try number 5, and then I'm not going to do all of the problems on the back of this. If you guys need more help, you can always rewatch this video, or you can contact me and we'll set up, like I said, some office hours. So first of all, let's go ahead and draw in our height. So the problem is asking us to find the area of triangle VKS. So VKS is this thing right here, and the area of WVKD. So the yellow and the blue. Okay, so we've got a triangle and we've got a trapezoid. So let's focus in on the triangle first. So I noticed right away that number 1, this trapezoid here is not isosceles, and here's why. This side is 10 and this side is 12. They are not the same. Therefore, it's not an isosceles trapezoid. So what I don't want to see is I don't want to see you guys label this as 30 degrees because that's not true. Okay, it's not an isosceles trapezoid. This angle is going to be different than this angle. Okay, so now that we've got that cleared up, we can move forward. I notice that since this angle is 30, this angle is going to have to be 60, and I've got a 30, 60, 90 right triangle. So we're going to reach for our ratios to help us figure out the dimensions of this. So I know the hypotenuse is 12, and if I reach for those special right triangle ratios, I know that the smallest side, which is opposite my 30-degree angle, is going to be half of the hypotenuse. So that means that the height of the triangle is 6. And then the other ratio is going to lead us to the solution that KS is 6 root 3. Okay. From there, I can go ahead and find the area of the triangle. I have my base, so 1/2 times the base, which is 6 root 3, times the height, which is 6. Okay, now remember when we're multiplying and we have an expression that has a radical in it, my favorite thing, and I stole this from Ms. Perrig, is innies stay with innies and outies stay with outies. So that means if it's outside the radical, we're going to multiply the numbers outside the radical. So that means I'm multiplying all the numbers together that I'm highlighting in blue. So I've got 1/2 times 6 is 36, and that root 3 is just going to come down. And then I'm going to just go ahead and multiply 1/2 and 36. Half of 36 is going to give us 18, and that root 3 is going to follow. So the area of that yellow triangle is 18 root 3. Okay, now we need to focus in and figure out the area of the trapezoid. Okay, so I know that the height of that triangle is 6. The height of this triangle is also going to be 6. The heights don't change, people. I also noticed that I've got a right triangle over here on the other side as well, and that looks like that's going to be a triple. So I've got 6, 8, and 10 is the hypotenuse. And since this side up here is 19, that means this side down here also has to be 19. So let me go ahead and outline this in blue. I've got everything I need to help us find the area of this trapezoid. Let's go ahead and start off by writing down our formulas. So that's 1/2 times base 1 plus base 2 times the height. 1/2, one of the bases, the one on top, is 19, plus base 2. Base 2 is going to be 19, this 19 plus this 8 right here. And so when I add that together, I get 27. Okay, and then our height is going to be 8. Okay, from there follow order of operations. So I have 1/2, 19 plus 27 is 46 times 8. I like to do 46 times 8 first, and that's 368. Take half of 368, and our final area is going to be 184. Are there units on this one? I'm just going to write units, U for units squared. I'm going to go ahead and write that up here as well. U for units squared. All right, guys, let's go ahead and turn to the back. So what I want you guys to do right now is let's go ahead and focus in on 1A. So for 1A, I want to draw your attention to the triangle that I'm highlighting in yellow. Okay. That triangle that I'm highlighting in yellow, this angle measures 30. The hypotenuse measures 16. Guys, what does this look like? It looks like a 30, 60, 90 right triangle, right? That's because it is, because I've got one angle measuring 30. That means the other side must obviously, or not the other side, the other angle must obviously measure 60. Reach for those ratios one more time. The side that is opposite your smallest angle is half of the hypotenuse. So if the hypotenuse is 16, this side must measure 8, which means this dotted line also measures 8. I don't know if you guys remember, but we can draw heights from anywhere in the triangle depending on how the triangle is drawn. So for example, if we've got an equilateral triangle, your height of the triangle is going to fall inside the triangle, okay? If we've got an obtuse triangle, your height is going to fall outside of your triangle. And if you've got a right triangle, then guess what? Your height is part of the triangle. It's one of the legs, okay? Let me go ahead and erase that. So now that I know our height of the triangle, I also know the base. I don't need to figure this out. They're not asking me to figure out the yellow highlighted triangle. They're asking us, what is the area of this triangle? So the one that I'm just highlighting in blue. I have all the information I need. I've got my base, which is 7, and I've got my height, which is 8. So plug and chug that into your formula. 1/2 base, which is 7, times the height, which is 8. So that's 1/2 times 7 times 8 is 56. Half of 56 is 28. So the area of that blue triangle is 28 units squared. Okay, I'm going to go ahead and leave 1B for you guys to do if you feel so inclined. If not, that's okay. I'm going to go ahead and skip down to number 3 because I think we could all use a little linear practice from time to time. So write the equation of the line that passes through the points -5, 7 and -3, 9. So write the equation of a line. Whenever we're working with linear equations, we need to find a couple things. Number 1, we need a point. And what's nice is that they give us 2 points to work with. Okay, so we've got that. The other thing we need to figure out is our slope. Okay, so if you guys remember, the letter that we use to represent slope is M. And to find it, we do your change in y over your change in x. So we do y2 minus y1 all over x2 minus x1. So I'm hoping this is ringing a couple bells for you guys. Okay, it does not matter which points you label as x1, y1, and x2, y2, so long as you're consistent. Okay, so I labeled my y2 as 9, so I'm going to do 9 minus 7 in my numerator. And then x2 is -3 minus -5. Now be careful. Some people often drop one of those minus signs there, and then they get their answer wrong. So after that, just go ahead and start simplifying. So 9 minus 7 is going to be 2. -3 minus -5. Well, what's going to happen there is that these signs turn into a plus. So we really have -3 plus 5, which is 2. 2 over 2 is 1. So our slope is 1. Okay. Now, when we're writing linear equations, there are a couple structures that we can reach for. So there's y equals mx plus b. And that's one that you guys are pretty familiar with. I mean, anytime I say, what's the equation of this line, half of you guys raise your hand and you go, y equals mx plus b. But you know what? That's not quite accurate. And for this particular problem, it's not going to help us because while we have our m, that's our slope, we just figured that out, we don't have our b. In this equation, the b represents your y-intercept. Okay, and I'd have to do a lot of work to go ahead and find that number. I really don't want to do that. So I'm going to reach for a different structure that we studied at the beginning of the year. And this different structure is y minus y1 equals m times x minus x1. Now, this structure is known as point slope form. M is your slope. That's easy, right? Now, what people often get tripped up about is this whole x1, y1 thing. These just represent a point on the line, okay? And then this x represents your input, this y represents your output. So as long as I've got a point, which I do, and your slope, you're good to go. You can plug and chug these into this structure. So I'm going to go ahead and pick the point -5, 7. So this is going to be my x1, y1. And I'm just going to plug those values into my formula. So I have y minus y1, that's 7, equals m. Well, my m is my slope, so that's going to be 1. And then x minus, because that's our structure, -5, because that's our x1. Now, if you notice again, I've got that thing here happening where I've got minus, minus. Yes, you can simplify that. You can rewrite this equation as y minus 7 equals 1, and then times x plus 5. You could have also left it in the way before we had simplified it. I'm okay with that, okay? But just understand that those are equivalent equations. You could have also used the other point. So if we had used the other point, which is -3, 9, we're going to plug that same, we're going to plug not those same numbers, but we're going to plug these values in for x1, y1. So I've got y minus 9, because that's going to represent y1. 1 is our slope, x minus -3. And then y minus 9, if we simplify it, 1, and then x plus 3. All 4 of these are equivalent equations. They all represent the same line. I will personally accept any one of these structures if you write them down on any quiz or test, but one thing that you guys want to familiarize yourself with is just simplifying. So these are like the simplified versions of the ones that they are written underneath. Okay, guys. So that's all I've got for you today. What I'd like for you to do is go ahead and try homework 805. If you need to, feel free to rewatch, pause, or rewind this video as many times as you need to until things make sense. If you have any questions, feel free to reach out and email, or you can hit me up on Remind. And don't forget to like, subscribe, and leave a comment down below. Okay, thanks. Bye.